So I often have friends reach out whose kids are having problems with mathematics homework. And now that I've been making videos all summer and most of this semester so far, I thought I'd go ahead and make a video because what they were asking a question about was the difference between converse, inverse, and contrapositive within logic. So I thought I'd explain the differences and go through a few examples. So if I have an if-then statement, like if it rains, then they cancel school, this is an example of an implication. And we typically would represent this with symbols like variables, and I'd have P implies Q. This means if P, then Q. The inverse of this statement would be not P, not Q. This tilde means not. It's to take the negation or to take the opposite. So the inverse of the statement, if it rains, then they cancel school, would be if it does not rain, then they do not cancel school. The contrapositive is the inverse kind of flipped. So if I was given, if it rains, then they cancel school, I need to flip Q and P. So I'm going to talk about school first and then rain and make them negative. So in order to find the contrapositive of if it rains, then they cancel school, I take the negative of that. So if they do not cancel school, then it does not rain. I'm assigning variables to the little sections of these statements. We call these compound statements. Okay? The last one I want to talk about, converse. So if I'm given a compound statement, also called a compound proposition, P implies Q, the statement Q implies P is the converse of that. So for example, if I hit a target, then a bell will ring. The converse of that would be if a bell rings, then I hit the target. We're flipping where each piece of our compound statement was before. So let's work through some examples just to make sure we've got a little bit more clarity. So here's first off a comparing of all three. So I have a statement that if two angles are congruent, then they have the same measure, right? We're relating this back to geometry. That's where we start to see a lot of use of inverse, contrapositive, and converse is in geometry. So let me write this in symbols. So let's let P be two angles are congruent. Let's let Q be they have the same measure. And remember this tilde symbol, this means not or negative. So the statement, if two angles are congruent, then they have the same measure. This arrow here means if then. I would have P implies Q. P if then Q. The converse of that is if it's flipped, right? So now I have, if two angles have the same measure, that's Q, then they are congruent, that's P, and I put an arrow between them because I have an if-then statement. The inverse is if two angles are not congruent, right? So P is when they're congruent, Q is have the same measure. I'd have not P, then they do not have the same measure would be not Q, and I've got an if-then implication right there. For contrapositive, if two angles do not have the same measure, then they are not congruent. So that would be, I have not having the same measure as Q. They're not congruent, that's not P, and I have an arrow between the two. So most of the homework problems involving converse, implication, and contrapositive are going to be wanting you to rewrite the sentence to find its converse, inverse, and contrapositive, and probably also write that symbolically. So let's go ahead and do another example. So, if you have visited Milwaukee, then you have been to Wisconsin. We're going to let P be visited Milwaukee, and Q be visited Wisconsin. Okay, so this is going to be P arrow Q, because remember this arrow remembers if then. The converse symbolically is going to be Q implies P. Now I wrote that in symbols first because then I think it might be easier for us to translate to words. So I have P, then Q. So if you visited Wisconsin, then you have been to or visited Milwaukee. Now let's think about this statement. Is this necessarily true? No, you could have been to Madison, you could have been to Green Bay, right? But we aren't asking whether this is always a true statement. Right now, as frustrating as that is, they really just want you to rewrite the converse, inverse, and contrapositive. Cool. So remember the inverse is going to be not P implies not Q. So that would be in words, if you have not visited Milwaukee, then you have not been to Wisconsin. The last example is the contrapositive, which is the inverse flipped. So it's not Q implies not P. So this would be, if you have not been to Wisconsin, then you have not visited Milwaukee. And I'm getting a little lax with the words visited and been to. Some teachers might be more particular about how that's done, but what really matters is that you're getting your point across. You're getting the negation where you need it, and you're flipping your two statements that you've been given. So let's switch it back to math. If two lines intersect, then their intersection is a point. Cool. So let's let P be, and I pick P and Q because these are the variables that we use the most. Let's let P be two lines intersect. And Q be at a point. So this is P implies Q. If two lines intersect, then their intersection is a point. The converse of that would be Q implies P. So if the intersection, changing the wording to make it sound better in English, so if the intersection of two lines is a point, the two lines intersect. And that doesn't sound the best. If their intersection is a point, the two lines intersect. Let me just say if their intersection is a point, the two lines intersect. Okay, that's better. The inverse of this would be not P, not Q. So if two lines don't intersect, then their intersection is not a point. If two lines do not intersect, then their intersection is not a point. Lastly, we have the contrapositive, which would be not Q, implies not P. So that's if their intersection is not a point, then two lines do not intersect. Awesome. Last but not least, I saw a problem that said, using P and Q below, write the symbolic statement in words, assume both statements are true. So the first thing I have is P implies Q, and then I have the inverse, right? Not P implies not Q. So let's let P be the value of x is 3, and Q be 2x minus 1 equals 5. So the statement would be if, so I'm putting my P, if the value of x is 3, then 2x minus 1 equals 5. Now I'm going to negate those sentences. If the value of x is not, that's what this little symbol means, right? Negation, not 3, then 2x minus 1 equals 5 is false. Or you could say 2x equals minus 1, let's write that as does not equal 5. So if you're middle schooler, high schooler, elementary schooler, has any math questions, feel free to put a comment on this video or send me a message, and I'd be happy to help.